I like solving equations. It's familiar territory. It's solve for x. So for rational equations, there's two methods. The first one is cross multiply, which you've been doing since algebra 1. Here's the only thing. That only works if you have a single fraction, an equal sign, and then a single fraction. If it's any more complicated than that, there's nothing that you can cross. You need to look up here and write this down. So if you have a single fraction equal to a single fraction, you can cross multiply. If it's more complicated, the other method is you multiply by the common denominator. And what that does, the point of that, is it's going to cancel out all the fractions. It makes all the fractions go away. Basically, in your first step, you should get rid of all the fractions, is what you're doing. Now, you also need to check your answers. Remember those troublemakers that we just talked about in the graphs? Same thing here. If you get an answer that is one of your troublemakers, you have to boot it out. So I usually decide what those are first before I even start the problem. Go ahead.
Will we ever without a common denominator?
You can always get a common denominator. It doesn't matter what's there. You can always get a common denominator. Sometimes it's not pleasant, but you can get it. It will always exist. Okay. It's kind of like when I'm grading the graphs, and sometimes for domain, people will put none. And I'm like, what are you doing? Like, you can't have a none domain. Like, there is one. Do you get what I'm saying? Like, it'll exist. All right. So looking at number 1, who are your two troublemakers? I usually write them off to the side. Who's -7 and -3. So do you see how I did the not equal to, like the no parking sign? If we get -7 or -3 as an answer, we have to dismiss those. So just write that first and then you'll have it there. Now this one we can cross multiply because we have a fraction equals a fraction. You're just going to need a whole lot of hugs. Okay. So give all of those a hug. Give 5 a hug too if you want, but it doesn't really need one. And then we're going to cross multiply. So you're going to have x plus 2 times x plus 3 equals, believe it or not, when cross multiplying, the most common mistake I see is people don't put an equal sign. It's not an equation anymore if you don't put an equal sign. And then what would I have on the other side? Times 5. And I'm going to put the 5 out front just so we can distribute that. All right, do you see how there's no more fractions? Your first step should get rid of all the fractions. You should have no more fractions. And now we're just going to multiply that all together. So x times x squared plus, I'm just going to throw the question out there. Good. Perfect. How did you get 5x? That is 2x plus 3x. Good. And then plus 6 equals 5x plus 35. Now, how do you know if you need to evacuate? If you have a squared, that's where you need to evacuate. Although this one turns out a little different because do you notice anything? Well, you always have to evacuate before you can factor, but is there anything you notice about this one that's like, oh, that's interesting? Yeah, do you see they both have a 5x? That means that they are going to cancel out. So we actually have x squared plus 6 equals 35. And so actually we don't really need to evacuate because it's a simpler problem. Usually if there's a squared though, that's where you need to evacuate, get it all equal to 0. But this one, because those 5x's cancel, it's less complicated. What would we do next? Yeah. Subtract 6, so that's going to be 29. X equals plus and minus square root of 29. It's not one of your troublemakers, so you're good.
Oh, I do remember this.
Yeah, I don't have to do any checking at the end because I kind of do it at the beginning. That's sort of personal preference. That's like my thing, but you know, whatever.
Floats your boat. Check your numbers in the top left corner.
Oh, I kind of just do it first, so I don't have to do it at the end. But yeah, whatever you want. All right, give some hugs. Oh, actually, you know what? We don't even need to cross multiply this one. If you're a good noticer, you can save yourself a whole lot of work. It's the same denominator, so those are gone. Oh, troublemaker though. Sorry, we were talking and I got distracted. Who would be the troublemaker? Even though those denominators are going to cancel, it still counts. -1/2 would make those 0, but it's a whole lot simpler of a problem. You can just do x minus 1 equals 2. So if you're a good noticer, you can save yourself a whole lot of work. Hey, Ms. Cole, you're very process driven and that's fine too. Hey, Ms. Cole, what if I did cross multiply and did all the steps? Would I get the same thing? Yeah, like it would still work. All right, add 1, you get 3, which is not the troublemaker, so we're good. Yeah, if you're a good noticer, it'll be pretty easy. I use a different color for these. If you want to, fine. Again, not, you don't have to. But the rest of these, they're not going to be cross multiplied. Do you see how you don't have a single fraction equals a single fraction? It's more complicated than that. You have three totally separate things. Now I'm going to tell you, obviously, I'm your teacher and I'm teaching to you, but I want to throw the question out there. What is your common denominator between these? Because I feel like we need an x, you need the 5, and you need the squared, right? So 5x squared. You are going to multiply 5x squared to everything. Hey, Miss Cole, I don't want to write it 3 times. That's fine. I'll just mark it wrong when you make a mistake later. Write it. Anyone can write the same thing 3 times.
5x squared is the.
You'll see why in a second. Let me do the next.
I remember that.
Oh, let me decide the troublemaker though. Who's our troublemaker? Who would make these denominators 0?
So,
0.
0 would make those denominators 0. The point of the common denominator is to get rid of the fractions. So watch what happens. We're going to do them one at a time. Well, yeah, you want to keep it as small as possible. So like, for example, if you have, a 2 and a 6, what would your common denominator be? No. 6. Let me say that again. If you have a 2 and a 6, the common denominator is 6. 12 would work, but you want to deal with smaller numbers. So pick the smallest one. Feel like I lost some of you. Take the variables out. Remove the x for a second. If you have a 2 and a 6, do you get how the common denominator would be 6? We're going back to 3rd grade. Y'all ready? We're going to go on a field trip back to 3rd grade. Say you have 1/2 plus 5/6. Your common denominator would be 6. This one already is 6, so you can leave it alone. What would you multiply this one by? We're doing the exact same thing except with variables. It's just a little bit more grown up. What would this give you? 3, 6 plus 5/6, which would be 8/6, and then that actually reduces to 4/3. This is exactly what we're doing, but with variables. It looks a little bit better now. Okay. I could just tell from the expressions. Let's go back to where we were here. Look at the first one. What cancels out in that first fraction? An x cancels out. How many x's? Just 1. Can I finish this problem? All right, just 1. So the squared is going to be gone because we canceled out 1x and then this x is gone. What's left? 5x times 4, which would be 20x. Good job. We got there. All right. Plus sign. What cancels in the second one? X squared. What you're left with is 5 times 1, which is 5. Equals sign. What cancels for the last one? Everything. And usually you get 1 where it's everything. And so all you're left with is 1. The problem kind of disintegrates is what happens. That's sort of what you want to happen. And now you're back to an algebra 1 style problem. What would you do to both sides? Yep, subtract 5. So that'll be 20x equals -4. Divide by 20. That would be -1/5.
Yeah.
Okay, cool. Thank you. Confirmation.
Just told me that one.
What is your common denominator for this? Oh, first of all, the troublemaker. I need to keep remembering that. What would make these denominators 0? 0. Now let's decide our common denominator. Who's your common denominator? 4x. You're going to multiply 4x to all 3 of those terms. Hey, Miss Cole, that 1 counts as its own term? Yep. If you want to write it as 1/1, if that helps you. But it is, every number can be a fraction. You just put it over 1. All right, let's go cancel out. What cancels for the first one? X. Now look at what you're left with. 4 times x plus 1. So you would have to distribute the 4 into that, and that would give you 4x plus 4. Good job. If you're working ahead of me, that's okay, but can you just make sure your answer's right? All right, equals. Now nothing cancels for this. You just have 1 times 4x, which is 4x. And then what cancels for the last one? Yeah, everything. 4x. And here's what's a little tricky about this. It all went away, but do you see this minus sign? you have to subtract the whole thing. Remember hugs, give everything a hug. You're gonna have to distribute that negative sign into here so that you're subtracting all of it. So everything's gonna flip-flop its sign. It's gonna be minus x squared, and then what? Plus 3x plus 4. Negative signs are difficult. They are the most commonly missed symbol all the way up through calculus, right? Always. Now we're gonna start solving. Do you see how there's a 4x on both sides? Cool, those cancel. Do you notice anything else? Again, if you're a good noticer, it will save you work. The 4's cancel. Do you see that? So over here, we've got nothing. Oh, it's already evacuated. Isn't that cool? Equals negative x squared plus 3 x. Now that's not a trinomial, so you can't split it. Don't like draw two sets of parentheses. Instead, it's greatest common factor. What can you factor out of both of those? X or negative x. Now it's personal preference, so I'll do whatever you guys want. Do you want to take out a... Okay, you sounded really sure of yourself. So we'll do negative x. If you factor out a negative x, you'll be left with x minus 3. Okay, now hold on. Let me get everybody else there. If you set negative x equal to 0, you will just get 0. Please don't overcomplicate that. If you, and I'm going to get to that 1 second. If you set x minus 3 equal to 0, you get 3. Now, this one was one of our troublemakers, but we still have an answer. Common mistake I get with that is people will write no solution. That's only the case if none of the answers work. Do you get what I'm saying? We got a solution. It's 3. You only had to throw out the other one. So we still got an answer.
So I have a question.
Yes.
Why, so I think I know why, but why did you, how are you able to cancel out everything that has a 4? And is it because of the common denominator?
Because if you moved it over, it would cost that anyways. It's just saving you interest.
Yeah, I was just saving some work. Like if I were to minus 4x from both sides, do you see how they would go away? And if I were to minus 4 from both sides, they would go away. Just instead of writing that, I just slashed it out. But that's mathematically what happened. All right, look at number 5. We hang out through this one. I'll give you a halfway. How many problems are there? 10? We'll do a break after 5. All right. Do you see this trinomial here? Even if just by instinct, what does it feel like you probably need to do to that? Okay, just write really small below it and we'll just factor it apart. So it'll be x and x, 1 and 3. And what are your symbols?
Plus and minus.
Good. Now here's my suggestion, and I'm not going to give you bad advice because again, it benefits me if all your grades are good. I tell everybody to scribble this out so that you're looking at the factored version of it. That is my suggestion. Okay. What is your common denominator?
1 times x minus 3.
Good. X plus 1, x minus 3. You're going to multiply that to all 3 of them. Hey, Miss Cole, I don't want to write it. That's fine. I'll just mark it wrong when you make a mistake. Anyone, my pep talk is anyone can write the same thing 3 times. That doesn't involve intelligence. You can do it. It doesn't even take that long. If you can't see what cancels and what stays, then you are far more likely to make a mistake. And I can't read with you because I don't know what on earth you did. I can't grade what happened inside your brain because I am not a mind reader. Who are our troublemakers? I need to keep remembering to write that. Yep, -1 and 3. I get that it's very redundant. Isn't that nice? Just do the same thing over and over again. That's kind of what I like about math. That's when I realized I could be good at this. Like, oh, just do that over and over again. I'm like, I can do that, you know? All right, so look at the first one. What cancels? X plus 1. See, you can see that cancels, and then you can see what stays. What do you have left?
5x minus 15.
Good. Oh, and you guys even distributed it. Nice. It'll be 5x minus 15. Good job. Jinx. Equals. What cancels for this one? Yeah, both of them. So just 6. Good. Plus, what cancels for this one? X minus 3. Now you would be distributing a 1 through there, but that's just going to be x plus 1. Do you see a squared anywhere? No, so it's not a very complicated problem. You don't have to evacuate or anything. It's just regular old algebra 1. First thing we're gonna do is put the like terms together. So just recopy the left side. This side would now be x plus 7. Then what? Subtract x. Add 15. What is that, 22? Divide by 4. 22/4 reduces, and at pre-calculus, it's expected you can reduce fractions. So 22/4 would be,
1, 2, 3, 4, 5.
What do I?
no one ever remembers how to say it. Yeah, it's halves. Everyone's always like 11 twos. That's not one of your troublemakers, so you get to keep it. All right, so look at number 6. What is your common denominator? X plus 2, and so our troublemaker is -2. And we're going to multiply x plus 2 to everything. Just write it 3 times. Just write it 3 times. Like anyone can write the same thing 3 times. You can do it. Believe me. You're going to check if yours is right.
Yeah.
I always did that in math too. Like the second I thought I started to understand it, I would like race ahead to see if I did it right. So what cancels in the first one? X plus 2, right? So what's left? X. If you don't write it, you won't see it. You have to see what cancels and what stays. Equals. Now you just have all of this because nothing canceled out. So you need to give a hug and then distribute the x through there. So that will give you x squared plus 2x. And then these cancel and you have -6. Now this one has a squared, so we need to evacuate, all right? You're gonna subtract this x over, here I'll write it so I don't lose anybody. And so you get 0 equals x squared plus what? Just x, good. You can put a 1 there if you want, -6. And the point of doing that evacuation is now you can factor it. So 6 will split into 3 and 2. And then I always do the symbols last. It'll be perfect. And so your answers are -3 and 2. Do we get to keep them both, get rid of them both, get rid of one? What do you think? Keep them both. Now this does mess people up and I 100% get why. -2 is your troublemaker, but +2 is okay. So you got 2 answers. Neat.
Just take the x out of the 2.
Sorry, say again.
Take the x, I mean, yeah, x out of the 2.
What do you mean x out of the 2?
When you're trying to evaluate.
Well, yeah, you're just subtracting this x to the other side so that it equals 0.
Oh, I'm so stupid. I thought you were.
No, you're just subtracting it over, just moving it to the other side.
Oh, you just, why would I think that? Oh my god.
Looks like a lot. All right, shh. Look at this one right here. It factors. If something factors, you have to do that first. Just write really small below it. What can you factor out of this? A 2, good. You would be left with x -1. And my suggestion, and I'm not going to give you bad advice, is scribble this out so that you're looking at the factored version of it. So what's your common denominator? 2 and x -1. Write it 3 times. It does not take that long. I just keep pep talking. You can do it. It does not take that long. It is pretty easy. Go ahead. Again, I messed up my sticky note. I could just pull it back out. Let's make up another one without x's in it. So say you had one, let me make it 3's this time. 3rd plus, but then that's another 3 and that messes people up. We'll do 5/12. Is the common denominator 3 or is it 12? It's 12. It has to be the bigger one because you could turn both of them into it. So what would you multiply this by? 4. This is exactly what we're doing just with x's. So this would be 4/12 plus 5/12. It has to be, do you understand? It has to be the bigger one because you could turn them both into it. I could potentially turn both of these into 2x -1. If I just take the x -1, then this one won't work. So it has to be the whole everything. All right, what cancels on the first one? X minus 1. You are left with 2 times X minus 6. So that would be, bless you. Good, perfect. Plus, the whole everything cancels, so just 10x equals, now nothing cancels over there because there wasn't a fraction. You just have to multiply it all together. 2 times 2 is 4, and you have to distribute it through there. 4x minus 4. Good job. Do you see a squared? No, so you don't need to evacuate. It's a simpler problem. Let's combine like terms. On this side, 2x plus 10x is 12x. Everything else just kind of gets recopied. I had that conversation with my Algebra 1 students too, because we're solving equations in there. Sometimes you just have to rewrite stuff. Just don't do a copy error. All right, then what? Oh, and I forgot to write down my troublemaker.
Yeah.
I just remembered that because I have a feeling this might come out to that. Who was our troublemaker? 1. I like to do that first. I keep forgetting to do that because we're having a good conversation. Because after I've scribbled it all out, I can't even see it. Because 1 minus 1 would give you 0. All right, so we're going to subtract over the 4x. Because I think it does come out. So you subtract over the 4x and then what? Add 12. And so x equals 1. 1 is your troublemaker, so you get rid of it, and your answer is no solution. I want to talk about that really quick because a lot of people feel abandoned by the problem. Like we have abandonment issues. The other thing I hear all the time is we did all that work for nothing. No, you did all of that work to get the correct answer. Also, no solution is actually a really interesting answer. Give me a number. That will not work. That won't work either. Give me another one. That won't work. That won't work either. There is no number on God's green earth that is going to work. So it's actually a really interesting answer to get. So you did not do all that work for nothing, is my pep talk for that. All right, what's your common denominator for this one? It is x squared, and I'm going to remember to do this first. Who's your troublemaker? Is 0. Good job. You guys have been good about those zeros. Usually that throws people, and you guys have been on top of that. So your common denominator is x squared. You're going to multiply that to everybody. So that is going to give you x squared equals, good, these cancel, so you just get 2. Now what cancels on this last one? Just one of the x's. So you're left with minus x.
Equals 2 minus x.
Good. Do you see a squared?
Yes.
Yes. So you're going to evacuate. Now, should I bring the x squared over to this side, or should I bring all of this over to the left side? You want to keep the x squared positive because we're going to factor, and it's just a lot easier to factor if the x squared is positive. So it'll be x squared. If I bring the x over, it'll be plus x, and then I'm going to subtract the 2 over, and it'll all equal 0. And then we're going to factor it and get 2 answers. Okay, hold on. Let me get everybody else there. You guys are so quick. X and x, it'll be 2 and 1. Good job. And so your answers are... These problems have a lot of steps, but you can start flying through them. Once you get the hang of it, you just start churning them out. Do you remember this from last year too? Like,
Yeah.
coming back to you, sir. All right, these ones have words. You're going to be okay. What are you doing? Hello? No, you don't need to do that right now. You can put that away until we're done with the notes. Thank you. All right, this says the sum. You with me back there? What does sum mean? Addition. So here's what I think you should do. Something plus something equals something else. Just write it with blanks. And that'll calm you down because you'll be like, oh, I have the setup. I just need to fill it in. Something plus something equals something else. All right, sum of 3 times a number. How would you write 3 times a number? 3x. Good. Plus 10 times the reciprocal of the number. So it's going to be 10 times the reciprocal of the number. Now, real quick, what's the reciprocal of 3?
1/3.
1/3. What is the reciprocal of 7? 1/7. Now, the number is x. So what is the reciprocal of the number? 1x, right? 1 over x, all right? You're reciprocating that number. Again, pretend it was like 9. You'd have 1/9, all right? And then is what? 17. Cool. Who's your troublemaker? What would make this denominator? It's the only denominator you've got in the whole thing. 0. Good job. And what is your common denominator? The only denominator there is. X. Good. You're going to multiply x to everything. It's the only thing that's in a denominator.
Points under it.
Yeah, 'cause
It makes it look like a fraction.
Wait, what is the x?
That's the common denominator.
Is that better?
Yeah.
Okay. Do you get why I did the blanks though?
Yeah.
Because,
Made it look like a fraction.
yeah, I got you. It's just some people don't know how to start. And I'm like, well, if you know what the word sum is, something plus something equals something else, it gets you started. Like it's the ball rolling, you know? All right. So what is this going to give us here? 3 x squared. Why is it x squared? Good job. X times x, that is x squared, plus 10. Good. 10 times 1 is 10 equals 17x. Let's knock it off back there. All right, do you see a squared? Yes, that means evacuate. You're going to subtract the 17x over. Be clever about where you write it. Where should I put the minus 17x? Yeah, in the middle so that you've got it in order. This looks like a fun factoring problem. I'm going to direct you to that sign right there. Gonna be okay. All right, so how would you split 3x squared? 3 and 1.
Oh, yeah. I was, oh, no, 5 and 2.
It will be 5 and 2.
5 on the other one, 2 and the one with the 3.
Okay, let's just guess and check. We're gonna guess that and check, see if it works. Because I think this is one of the ones where the number works both ways, but the symbols are wrong, one of them. So let's just check. What are the outsides given us? 15x and 2x. They'll both be negative. Now we are correct. Again, if you did it the other way around, your number came out right, but your symbols are wrong. Look, do you see how a negative times a negative is a positive? If you did it the other way around, you had a plus and a minus. It just won't work out. All right. So 2 answers. What's the first one? It's 2/3 and then 5. What was that?
Clear.
Clear.
They don't equal-
Oh, yeah, they don't equal. Oh, is that what you say? Clear?
Yes.
Okay.
Yeah, like what?
Yeah, I didn't know if that was like new jargon or something. All right. I had a student one year that said boom every time we finished a problem. Every time we were done, boom. I was like, okay, cool. Yeah, right. Like mic drop. All right. Last one. Jack can find a. I was being silly when I made up this question. Have a good one. I made it about Jack and Jill finding a needle in a haystack. But listen. It's like you know what? We'll just wait. Are you guys listening? It's the last one. If one person can do a task in a certain amount of time, and another person can do the task in a certain amount of time, if they work together, they should be able to do it faster. Thank you. Do you get what I'm saying? Okay. So Jack can find a needle in a haystack in 3 hours. Jill can do the same thing in 5 hours. If they work together, our answer should be what? Smaller than 3. They should be able to do it faster than 3. Let's write that. Smaller than 3. If we get an answer bigger than 3, we have done goofed. Because if he can do it in 3 hours and she's helping him, it should be faster, right?
Is that our?
No, we didn't write an equation yet, so we don't know what the troublemaker
Well,
is.
what happens if he like slows them down or?
We only do the math, we don't do the physics. Okay? So what we're going to do is what they can do in 1 hour. Why 1? It's the simplest number to deal with. Miss Cole, could I do 17 if I wanted? Sure, but why on earth would you do that? All right. So if he can find it in 3 hours, here's the $1 million question. What fraction of the way finished is he after 1 hour?
1/3.
Okay, so we get 1/3 x plus,
1/3, 1/3.
well, or x over 3, if you want to put the x in the numerator, you can. Now, she can do it in 5 hours. What fraction of the way done is she? Good, or 1/5 x. I like writing it that way. You can write x over 5, that's fine. Equals 1. Why does it equal 1? Because we did 1 hour, and you want to pick 1 because it's an easy number. So this actually doesn't have any troublemakers because we ended up with no x's in the denominator. But we do still need a common denominator. What is your common denominator? 15. You're going to multiply 15 to everybody. Do you guys understand how she got 15?
You do it multiply or multiply?
5 times 3. Okay. So what do you get here? 1/3 of 15. So 5x plus 3x equals 15. 1 times 15 is 15. Do you see a squared?
No.
No. So you don't have to evacuate. It's going to be 8x equals 15. Okay, now hold on. I'm not done talking about it. We need units because it's a word problem. It's 15/8 hours. And is that smaller than 3? Well, 16/8 is 2. So it's actually even a little bit smaller than 2. So working together, they did the task faster. I made it silly about finding a needle in a haystack, but the common problem you get with that is you're filling up a swimming pool and you have one hose that can fill it in a certain amount of time and another one that can fill it in a certain amount of time. How long will it take if you use them both together? I was just being silly with Jack and Jill here, but it's the same concept.
So